This is part 2 of my video series about this formative on coordinate geometry and linear functions. And in the first video, we went through the first 5 questions, and really that was all about generating this graph right here. And in the next few problems, we're actually going to start working on trying to understand the equations of these lines, or at least one of them. Here in question 6, it says, find the equation in slope-intercept form of line B. So here's line B right here. And what we know about line B from question 3 up here is that it goes through these 2 points. So we can do a couple of things here. I could actually use the slope formula, and I'll do that right here. I can use the slope formula, which is the slope m is equal to y2 minus y1 divided by x2 minus x1. And if I take the y values from these 2 points, 3 minus a negative 1 on the top, and the x values, 2 minus a negative 6, that should give me the slope. Let me keep working on this a little bit. 3 minus a negative 1, that's 4. 2 minus a negative 6, that's positive 8. This is 4 over 8, which is equal to 1/2 when I reduce it. And so that's the slope of my line. And then notice the other thing that is that you might notice that I can really get that 4 and that 8 directly from the graph. Look, if I start on this point that I plotted and I go up 1, 2, 3, 4 units, and I go over 1, 2, 3, 4, 5, 6, 7, 8 units, I get right to the other point. So I can see that this slope triangle, which I'll just draw really lightly here, has a rise of 4 and a run of 8. And it's a positive slope because it's increasing. So that's where these 4 and 8 actually come from, and on the graph. Now that I have the slope, if I'm going to write my equation in slope-intercept form, that looks like this. Y equals mx plus b. You'll remember that's slope-intercept form. And this here is the slope. And then b is the y-coordinate of the y-intercept. And to me, it looks like it's probably 2. It's probably right about 2. According to the graph, I expect the y-intercept to be 2. But I don't need to make that assumption either. I can just plug in my slope here, 1/2 x. I just got my slope there, and I'm just going to leave this as a b. And I don't know what b is yet exactly. I have my hunch that it's probably about 2. But now let me just take a point like this one that I know is on the line, 2, x equal to 2, y equals to 3. And I'm going to plug that in here. If y equals 3 and x equals 2, I can substitute those values into this equation. And now I can solve for b. Let's see what happens. 1/2 of 2, that's just 1. So this is 3 is equal to 1 plus b. And from here, I think you can probably see that b is equal to 2, just as I suspected. So I'm not. Sometimes it's difficult to know exactly what the y-intercept is from the graph. So it's good to engage in a little bit of algebra to really show that we know the y-intercept. But taking this information together, I can write my final equation in slope-intercept form. Y is equal to 1/2 x plus 2. That's slope-intercept form. And I'll just put a box around it. Okay. In the next question, we're asked to find the equation in standard form of line B. So it's basically this equation, but I need to write it in standard form. And you'll recall standard form of any linear equation looks like this. Ax plus by equals c, where a, b, and c are integers. And so I clearly have a fraction here in my equation, but I'm going to begin by copying my equation in this form. And to eliminate that fraction, I'm just going to multiply everything by 2. And I didn't leave a lot of space to work vertically, so I'm going to work horizontally here. If I multiply everything in this equation by 2, I get 2y equals x. Remember, the whole point of multiplying by 2 is that when I multiply this term by 2, the 2's will cancel and we'll just be left with 1x. And don't forget to multiply the constant term also by 2. That gives me 4. So look, I've almost achieved standard form just by doing that one operation. The next thing that I need to do is make sure my terms are all in the right order. I need my x term first, and then my y term, and then on the other side of the equation, my constant term. So all I really need to do is subtract the x from both sides. It'll cancel out from this side, and I'll be left with a negative x on the left-hand side plus 2y, and that's going to equal 4, which is my constant term that's left over on this right-hand side of the equation. So that's it. That's standard form for this equation. And just to notice, my coefficient of x right here is -1. That's an integer. My coefficient of y, that's 2, also an integer. And then my constant term is 4, also an integer. So I meet this requirement of standard form, and then I've listed my terms. I've written my terms in the proper order. The term with the x, plus or minus a term with the y, and that equals the constant term. And so now I'm done with number 7, and then question 8 asks if lines A and B are perpendicular, and how do we know that? Well, first of all, let's look at these lines. They look pretty darn close to perpendicular to me, right? This looks to be about a right angle right there. And if that's true, then there's a relationship between the slopes. And I'll notice the slope of line B is 1/2, and of course you'll recall that the slope of line A is -2. And these, I can say that line A is perpendicular to line B because their slopes are negative reciprocals. Right? If I take the reciprocal of 1/2, that gives me 2/1. The reciprocal, again, is when we flip the fraction over. Well, that's just the reciprocal of 1/2 is 2. And if I take the negative reciprocal, then that gives me -2. So because these slopes are negative reciprocals, these lines are perpendicular. In the third and final part of the video, I'll be talking about this last question, number 9, and that's a question about distance.